I'm doing it. Okay. So this is the representation of one class. Okay, one class, that is customer loan. So each class will have two types of members. One is member variable, other one is member functions. Member variables are also called as attributes and member functions are also called as methods. Okay. Since for the customer loan, bank has to collect the details of these four attributes. These customer ID, loan amount, interest rate and duration will become the variables or attributes of customer loan class. And in order to set the values for these four variables, set customer ID, set loan amount, set interest rate and set duration functions will be used. And to return the values, okay, to return the values of customer ID, loan amount, interest rate and duration, get function methods will be used. And so there will be 8 functions, just set and get, 4 set functions and 4 get functions. And there is a last function, if you can notice, calculate EMI. That is what the scenario says here, right? EMI has to be calculated based on loan amount, interest rate and duration. So by considering these 3 values, EMI will be calculated and that will be the last method of customer loan class. Okay. This particular representation of the class happens in the class diagram. Okay. When we say a class diagram, it is not just one class actually. It is the representation of multiple classes to be used in one case study or one scenario. Okay. So, but the representation of one class in the class diagram is like this. Fine. This class diagram can be implemented using any of the object-oriented programming languages. You have C++, Java, C#, and so many object-oriented languages. So we generally go with C++ or Java, and in your syllabus, it is Java. Okay, the implementation is done with the help of Java. Fine. Let us see how is this class implemented. We are not bothered about anything else here, just these member variables and member functions. How are these represented for a class? Okay. So the name of the class in the previous diagram you have seen, it is customer loan, right? Class name, that is customer loan, and you open the curly bracket. So whatever you write inside that will be a part of this particular class, member variables and member functions. Okay. So the 4 member variables are of type private. Always when you create a class, make the variables as private and functions as public so that the functions can be invoked inside any other class. Okay. So there are 4 attributes which are represented in the class diagram here. Customer ID, loan amount, interest rate and duration. So private int customer ID, private double loan amount, private float interest rate, private int duration. So the first word is a access specifier, then it is the return type, and then it is the name of the attribute or name of the member variable. Okay. Once you are done with the member variables, your next section starts, that is the member functions or member methods. So as you can see in the diagram here, first 4 methods are set functions, right? Set customer ID, set loan amount, set interest rate and set duration. These functions are used to give the initial values to the member variables. Okay. To initialize the member variables, we make use of the set functions. Okay. Set customer ID of int ID. Assume that your int ID, it is an integer value, say it is 10. Then customer ID will be initialized with value 10. Similarly, say the loan is 1500. Then set loan amount will initialize loan amount to 1500. Then rate of interest. Next, set interest rate. Assume that the value of rate is 5.5. Then interest rate will be 5.5 because you are initializing it. Interest rate is equal to rate. Similarly for set duration. After initializing the values of the member variables or member attributes, get functions are used to return the values. Public int get customer ID will return the customer ID. Okay. Similarly, public double get loan amount, because loan amount is of type double there, right? So that is you return the loan amount. Similarly, you return the interest rate, you return the duration. Okay. Then after returning the values, there is a last function which is to calculate the EMI, and calculation of EMI happens by considering the loan amount, interest rate and duration. So with the help of the formula loan amount plus loan amount into interest rate into duration by 100, you get the EMI amount to be paid every month. So that you are printing using system.out.println. Okay. I am not explaining you the syntax because syntax you can learn, but what we are concentrating here is just the concept. Okay. This is the implementation of a class called customer loan. Fine. So every member variable have to be declared and every function have to be defined. Okay. Just to see what that particular function does. Fine. So there are 4 attributes or 4 member variables. Hence, there will be 4 functions to initialize these member variables, and there will be 4 functions to return the values or the initial values of the variables. And finally, as per the case scenario, calculate EMI will be calculated with the help of loan amount, interest rate and duration. Okay. This is just mapping of class diagram to the code or the implementation. Okay. One class, that is customer loan, is implemented in Java like this. Okay. You can see the clear distinction of the sections. Okay. Class name, then the member variables, and then the member functions. Any doubts so far?
No, ma'am.
Okay. Now you have a clear idea about what you mean by a class, right? You can create a class, you can write the member variables, you can write the member functions. Then what do you mean by an object? Fine. So class comes first, then comes the object. Fine. Once you create a class, okay, you should create the instance of it. The instance of it or the instance of a class will be mapped to a real world object, okay, or a real world thing which we call it as object. Okay. In general, object is an instance of class. Okay. And when you create the instance, each instance will have its own values to the member variables. Every class will have some set of member variables, right? When you create an object, that with respect to the object, you can have the values to those attributes. Okay. One class, say customer loan, can have 10 objects, because see, customers, there will be 10 customers who are taking the loan, right? Each object will be a customer. Okay. First customer, I will make the object as object 1. Second customer, object 2. Third customer, object 3. The reason for creating multiple objects is that the details or the attribute values of each customer will be different. They cannot be mapped to a single object. That is why every customer who is taking a loan will be an object for customer loan class. Hope I am clear. Okay. So if there are 10 customers who are taking the loan from the bank, there will be 10 objects created, each one for a customer. Okay. And each object will hold the details of that particular customer. Okay. Object 1 will hold the details of customer 1. Object 2 will hold the details of customer 2. They are different, and one object can be just mapped to one customer. Okay. That is a concept of object. You can see in the diagram here, not the diagram, a screenshot, where there is a customer loan class which is already created. Okay. There is a customer loan class which is already created. Now there is another class, say class bank. Okay, that is a very general class. Inside the class bank, there will be customers. Okay, now every bank will have customers, right? So customers can take the loan. Whoever is a customer of the bank can avail the loan from that particular bank. So inside a bank, for a customer to avail the loan, okay, anyway, a separate class has been created. Now I have to create the object. Okay, for one customer, one object. Then how do you create the object? You can see the second line inside the main function. Public static void main is a main function in Java, which takes a string args as parameters, its command line arguments, a kind of. Then inside that, that is a syntax. Okay, how we write void main of something. This is the syntax in Java. Then inside that you have the creation of object. Customer loan obj1 is equal to new customer loan. Customer loan is a class name and you are creating an object of that particular class. Obj1 is the name of the object. So obj1 is the object of class customer loan. Okay, is equal to new customer loan. That is the syntax. When you do actually new customer loan, it's a kind of default constructor which you will be learning later. Okay, just to initialize the attributes with some default value while creating objects. See, when I create an object for the customer, there is one customer who is coming to the bank and asking for the loan. Okay, initially, when I create the object of that particular customer, the details, whatever is required, maybe the loan amount, duration, interest rate, etc., will all be set to the default value. Okay, then once the customer fills the form and everything, the actual values will be set. Okay, but when the objects are created, the default values will be set for that particular customer. So customer loan obj1 is equal to new customer loan, and it is a function. Customer loan, you can see new customer loan is a function there, semicolon. This is how an object has been created for the class customer loan. Okay, once you create an object, the details like customer ID, loan amount, interest rate, and duration can be set with respect to this particular customer or this particular object. So object 1 dot set customer ID, object 1 dot set loan amount, object 1 dot set interest rate, object 1 dot set duration. This is based on the requirements of the first customer who is taking the loan. Okay, he will be given a customer ID, that is with the help of set customer ID. He will mention the loan amount, that is what is being set to the variable loan amount, again the interest rate and duration. Okay, then if you want to display something, get customer ID, get loan amount, get interest rate, get duration will be used to display the values. Okay, to display the values. This process can be repeated for any number of customers. Object 1 is one customer for this customer loan. For the second customer, I have to create a new object, say object 2. Okay, and I repeat. I fill in the values for their customer ID, loan amount, interest rate, and duration, and I print it to the user. If there is any third customer, third object will be created, and so on. Any doubt here? This is very important and the basic thing for you to understand. Any doubt? Any doubt here? Okay. Now you know the meaning of a class, you know the meaning of an object. Then what is the difference between class and object? Okay. So it's very straightforward. It's already given here. Class is a blueprint of the object. You cannot do anything just with a class until and unless you create an object of it. Okay. The object is the actual representation of the class. Okay. Actual instance of the class, which is mapped to a real world object. Class is a kind of blueprint. Okay. You will say, I have these many member variables. I have these many functions. Only when you create an object, you will have the actual use of those classes. Okay. Next comes another important concept of OOPs, that is called as constructors. Okay. One very important or unique characteristics of this constructor is a function. Okay, constructor is a function or it's a method. And the name of this constructor is same as the class name. Okay, there is a class name, say customer loan. And when you have a function with the name customer loan, then that function is nothing but a constructor. Okay. Constructor is a specialized member method which has the same name and as the class, and the constructors do not have a return type. Okay, they will not return any value. Basically, these constructors are used to initialize the variables of a class. Okay, to initialize the member variables of a class. So this initialization can happen while creating the object. I told you when you create an object, say customer loan obj1 is equal to new customer loan. That is actually you are creating an object plus you are initializing the variables to the default value. That is a concept of default constructor. That is why I stressed out that it is new customer loan. Customer loan is a function. Customer loan is a class and customer loan is a function there, right? So that is basically while creating an object, you are calling a constructor to initialize the member variables. Okay. There are two types of constructors in OOPs. One is the default constructor and other one is a parameterized constructor. Okay. Default constructor is when you create an object. Okay. When you create an object, if you are doing it. Okay. One way in the previous example you have seen new customer loan obj1 is equal to new customer. There is no argument. There is no value you are passing to this function customer loan, right? It doesn't take any arguments. Yes, constructors do not return any value, but the default constructors do not even take any arguments. Okay. So when they do not take any values as arguments, the member variables will be given the default value. Okay. So look at the example here. Inside the main, this is the same code which we discussed just now before. Okay. Customer loan obj1 is equal to new customer loan. You are calling customer loan is the name of the function. So when you do it, when you call it as a function here, it is a default constructor. So obj1, I told you that it is when the first customer comes into the bank for availing the loan, he will be given or an object will be created for that customer, that is obj1. And initially, before we obtain his data, the default values will be set to that particular customer. Okay. That is done with the help of this new customer loan. Okay. The constructor will set the default values to loan amount, rate of interest, duration, and customer ID. Okay. So soon after calling this constructor or soon after creating this object, if you try to display the values of any of the variables with respect to this particular object, then you get the default value being displayed. Customer ID, it is an integer value, so 0 will be displayed. If it is a float, 0.0, etc. Okay. Since you are not redefining the constructor, instead you are just calling it when the object is created. Okay. You are using this constructor during the creation of the object. That is why the default value is being set. Okay. There is another way of using this default constructor which you can see here. A class inside the customer loan class, there is a function customer loan. Okay, name of this customer loan or name of this function is same as the class name. And inside this constructor, even though it is a default, it doesn't take any argument. So when the constructor doesn't take any argument, it is called as default constructor. And inside this default constructor, the variables are initialized. Okay. customer ID is equal to 1001, loan amount is equal to 20,000, and so on. All the four variables are initialized. Okay. Now, in the creation of object inside the main function, when you do new customer loan, okay, even though you are calling the parameterized, default constructor here, since this constructor is redefined inside customer loan, the variables will not be set to default value. Instead, this customer loan calls the redefined default constructor and initializes customer ID with 1001, loan amount with 20,000, interest rate with 3.5, and duration with 2. Okay. So, since this particular constructor, default constructor, is redefined inside the customer loan class, values will not have the default or the variables will not have the default values. But when this redefinition is not done for the constructor, only then the variables will be initialized with the default values. So this is a second method of using the default constructor, and this is the first method of using default constructor where there is no redefinition happened anyway. You are just defining it here. You are just calling the constructor here, and hence the variables will be given the default value. But in the second case, they are redefined inside the customer loan class, and hence when you call it while creating an object, the variables will be given the variable or the function or the constructor in turn calls the redefined constructor. Okay, these are the two ways you can use the default constructor. And there is another type of constructor in OOP. We call it as a parameterized constructor. As the name says, we are passing the parameters to the constructor, or we are passing the arguments to the constructors while calling the constructor. Okay. So you can see the example here. Okay. While creating or while defining a constructor, you are passing the parameters. Public customer loan, int ID, double loan amount, float rate, int duration, and these values will be passed to the member variables. Okay, or they are member variables are initialized with these values. Now, when you create an object, you can pass the actual values. Okay, you can pass the actual values. 1001 will be mapped to ID. 20,000 will be mapped to amount, and so on. This is another way of initializing with the help of parameterized constructors. Any doubts?
No, ma'am. This is one concept in OOPS, okay, which will be used in most of the situations, okay, while we program. What is happening in any programming language generally is that when you create a global object, global variable and local variable with the same name, the local variables hide the existence of global, which you might have observed in C, right? Say there is a global variable called ID and there is a local variable called ID. And when you try to use it inside the function, the variable ID, if that ID is local, it is automatically mapped or it hides the existence of global ID. Just a minute. Sorry. So it That is what it hides the existence of global variables. Similarly, in Java, okay, similarly in Java, when you have, look at the example here, okay, look at the example here. There is a member variable called ID, and inside the function shape, there is a local variable named ID. Okay, in here, in case of OOP, there is nothing called as global. Everything is member variable or it is local. Fine. So there is a instance variable called ID and there is a local variable ID. Now, when I use this ID inside the function shape, which ID it refers to? It refers to the local ID, right? Int ID. It is not a member variable ID. Instead, it is a local variable ID. That local variable is hiding the existence of the instance variable ID or the member variable ID. So if I want to use the member variable ID inside the function shape, then I use the keyword this. Okay, that means it is kind of pointing to the current object. Okay, current object. Fine. So the current object, its ID is equal to the local ID. Okay, so it how can I say, it is like a method to stop the hiding of instance variable. Okay, instance variable will not be hidden or the member variable will not be hidden. The member variable can also be used along with the local variable even though they have the same name. Fine, that is a concept of this reference. And there is one more concept called static. Static you are almost aware of. You have done it in C also. Since you all have gone through the concept of PSUC, lab, you are aware of static. So the usage of static is same here also. Okay. Static variables are also called as class variables. Fine. In order to get a variable manipulated, okay, multiple times, when a function is called multiple times, we use the concept of static. Okay, static methods or the static variables will be accessed inside the static method and non-static method, but static methods cannot access the non-static variables. Okay, so this, I think you will better understand when you start using it. When you start using it, fine. So the program, what happens, or the program, how it works here is, there is a counter with the initial value as 1001. When it is incremented for the first time, since it is post increment, for the first iteration it is 1001, and for the second object, again you are calling the same uh, customer loan constructor where it is again incremented, right? So it is basically incrementing starting from 1001. Fine. But for the first time when it is called, it will be set to 1002. Fine. Sorry, 1001 because it is post increment. For the second time you call, it is 1002. For the third time you call, it is 1003. The multiple calls will increment the value. They will not reinitialize. The reason is counter is made static. If you remember in C, when we do a recursion, if we do not want to reset or reinitialize or call the reinitialization statement every time a function is being called, we use this concept. When you make a variable static, that static initialization will happen only once in the program, and for the next function call, that initialization statement will be skipped. Okay, and automatically it keeps incrementing. Otherwise, what happens is, for the first object also, it initializes with 1001 and increments. When you create a second object, again initialize it with 1001 and increment. So every time the value for every object will be 1001 only. Once you make it static, where for the first call of customer loan, okay, for the first call of customer loan while creating the object, for the first object, it is incremented. So 1001. For the next object, another increment 1002. For the third object, 1003, and so on. Okay. If you do not make it static, for every object, it is 1001 only. Okay, that is the difference. That is why
You make any of the variables static. That is the end of third chapter. Any doubts here? Any doubts? Otherwise, I'll start with the next chapter. Any doubts here?
No, ma'am.
All right, if there is no doubt, let's start with our next chapter, okay, where we will be discussing some more advanced concepts of OOP, okay, such as relationships, inheritance, polymorphism, and so on, okay. These are all some of the advanced concepts of OOP, and let us start understanding them one by one. First comes, it is relationships, okay. So, as I said, one case study if you consider, or any real world application you consider, it will have more than one classes, definitely, okay. So when you have more than one classes, of course, when you have one class, there will be multiple objects. Then when there are, say, multiple classes, say 100 class for a scenario, for a case study, there will be so many objects, so many instances, right? But there is some relationship among these classes and the objects you create, fine? Identifying these relationships is very important, okay? When you are creating a bank, say, bank system only, let me consider, okay? There will be customers, there will be different types of loans, there will be different types of deposits. These are all the classes, okay? When these are all the classes, of course, they are interrelated, right? Then identifying the relationship among these classes and the objects are important to have a design deployed, okay? So again, there are three types of relationships, basically main three types of relationships. One is a relationship, second one is has a relationship, and third one is uses a relationship, okay. Is a relationship is a kind of something, has a or a part of, okay, and user. We'll study each of them in detail, fine. And to understand these relationships, let us take the same case study which we discussed in the previous chapter, okay, for providing different types of loan, okay. The bank is in the process of developing a system, okay, and while developing a system, the system should incorporate the different types of loan offered by the bank and different type of customers who are taking this particular loan, okay, and their relationships have to be studied and implemented, fine. So to understand the relationships, let us restrict ourselves to one category of classes, that is loan category, okay. So what are the different types of loan offered by the bank? There will be housing loan, there will be consumer loan, there will be business loan, there will be large business loan, and so on. There will be so many others, okay. And each of these loans have different criteria or different requirements, fine, which you can see here. Right? Each of these loans will have their own requirements or their own criteria. Now, or in the process of developing this particular system, as I said, there are many relationships, right? Is a relationship, has a relationship, uses a relationship. First one is called inheritance, has a relationship is called aggregation, and third type of relationship is called association. Okay. Now, is a relationship. I know that the bank is providing a loan, and if I am availing, of course, there are many types of loans. If I am taking a personal loan is also a loan, right? Personal loan is a loan, okay? So, personal loan is a type of loan. I can relate them like it. It's a simple relationship, okay? Personal loan I take is a type of loan, okay. That means personal loan is a class, loan is another class, and this personal loan is a type of this loan class. Similarly, housing loan is a type of loan, okay.
So this is similar to another class. A class is similar to another class, or I can say this class is a type of another class. That is a simple relationship. That means housing loan has all the attributes of loan, plus it can have some additional or some differentiating factor. Okay, because they are not exactly the same. If they are exactly the same, there is no type created for it. It is not required, right? I do not have to separate it as housing loan. I can just consider it as loan. There is something different for housing loan when comparison or when compared with the loan. There is a clear distinction. Okay, so that is the first type of relationship, is a relationship. Now coming to the second type, housing loan. For availing the housing loan, okay, the person who is taking the loan has to furnish his property details. Okay, so the customer who is taking the housing loan has to furnish his property details to the bank. The property details will have, say, document number and so many other things, right? His address, his property holder name, and so on. Okay, so that constitutes another class, because there'll be a person can have multiple properties, right? So one property will have one set of details. Okay, so that will form another class. So this housing loan has property details, and this property details will have address, right? One factor, say, property details could be property holder name, address, and document number. Then address is another what I say important attribute, which can again be a class. Why? Because address can be having some address, line 1, line 2, city, zip, state, and so on, of different data types, right? So again it can form a class. Okay, so it is a kind of housing loan has the property details, and property details has address. Okay, so property details is a part of housing loan, address is a part of property details. Okay, I think you can clearly understand. It is a simple English statement kind of thing. Housing loan has property details has address. Okay, or in other words, or in reverse. Okay, address is a part of property details and property details is a part of housing loan. Okay, so that is has a relationship. And the third one is uses a relationship. One class uses another class. Okay, one class interacts with another class. Loan advisor, for creating the loan object for every customer, he has to interact with the loan class, because he has to create the loan object. Okay, it is simple. It is as simple as this. In the bank, there will be a loan advisor. When a customer approaches the loan advisor for the bank, he should create the loan object, because he is providing the loan. So for creating the loan object, he has to interact with the loan class. Okay, so that is the interaction. He is using the class. Okay, one class is using another class. That is uses a relationship. So let's study each of them in detail. Okay, first one is the relationship. As I said, housing loan is provided by the bank. So what are the attributes of this housing loan class? There will be a customer ID, there will be a duration, there will be an interest rate, there will be a loan amount, and there will be a type of interest. Okay, these are the attributes specifically for housing loan. Okay, specifically for housing loan. And if there is any other type of loan, the attributes could be different. Okay, some of the attributes could be different. Fine. So if these are the attributes of housing loan, you can see the class diagram of housing loan. The first diagram is the class diagram of housing loan. Okay, customer ID, duration, interest rate, loan amount, type of interest. And there is one property details, because it is housing loan, the property details have to be furnished. Okay, and then set and get functions. Set and get functions. This property details is not actually an attribute, it is a class. Okay, property details class. It is linked to another class called property details. That is why it is property details colon property details. You can see it is not a variable. Okay, it is a class. One class is depending on another class, like that it is. Now, they are associated when you say that there is a relationship. Okay, that housing loan is a loan. Fine. Loan will have customer ID, loan will have duration, loan will have interest rate and loan amount. But in general, a loan will not have type of interest. Okay. It is specifically for a type of loan. Say housing loan has a type of interest as floating or fixed or some types of interest. But in general, a loan will not have the type of interest. It is like you take this particular amount, how much ever you want, on this much of the interest, this is the EMI you are supposed to pay for this much of the duration. Okay, that is a criteria of loan. But when it comes to the housing loan, they will give the customer two options. Do you want to go with the floating interest rate? Do you want to go with the fixed interest rate? And so on. Okay, they are different or they are specifically for housing loan. Okay, which is not there in loan. That is why housing loan is a loan with an additional attribute of interest type. Okay, okay. I cannot directly use a relationship when two classes are exactly the same. There is no purpose of using is a relationship. Okay, when two classes are same, it is like a redundant one. Okay, I can use keep any one and remove the other one. Okay, but if a class has an additional member or an additional function, then the class housing loan has an additional member plus it uses all other available attributes and functions of loan class. Okay, that is why housing loan is a loan with an additional attribute of interest type and the get and set functions of interest type. Only then it is a function. It is inheritance. That is, housing loan is using the variables and functions of loan class, plus it will have an additional attribute or additional variable and function. Only then I can use is a relationship. Then comes has a relationship. Okay, this I think I have clearly explained you in the previous slide only. Housing loan has property details and property details has address. The reverse, completely reverse of it is address is a part of property details and property details is a part of housing loan. Okay. I have explained you, that is why I do not want to repeat the same thing. Fine. Has a relationship is the opposite of part of relationship, and has a relationship is also called as aggregation. And the diamond box, whichever you can see the connection or the message passing link between housing loan and property details, you can see a diamond box, right? That is specifically used for has a relationship. Okay, housing loan has property details. That means you are including property details in the housing loan. You can see the last attribute in the member variable column. The last attribute is property details. That means you are including the property details class inside the housing loan class. Okay. Similarly, in the property details, you can see address is included, the middle one, right? First one is property holder name, second one is address, which again forms a class. So that you are including inside the property details. So property details has address in it. Housing loan has property details in it. Okay. So the reverse is address is included in property details. So address is a part of property details. Property details is a part of housing loan. And the last type of relationship is called as uses a relationship. Okay. So this uses a relationship is kind of loosely coupled relationship, we call it as, okay, compared to other relations. And another name for this uses a relationship is association. Okay. Generally, in object-oriented programming, objects interact with other objects to do something useful. One object, one class, what to do? Okay. To have some real-world applications, there will be multiple classes, hence there will be multiple objects. Each of these objects are supposed to communicate. Okay. So the for initiating these communications, we require the concept of relationship. Fine. See, there is a loan advisor. Okay. And loan advisor has to initiate the loan for a customer. And let's assume that there is a initiate loan function for loan advisor. You can see the last function of loan advisor. It is initiate loan. For initiate the loan, or to call the initiate loan of loan advisor method, it requires the loan object. Okay. Initiate loan means it is supposed to initiate the loan. So the initiate loan is in turn, it is mapped to the loan class or loan object. Okay. So it uses loan object. For calling this initiate loan function, it should use loan object. Okay. Because when it is a loan amount, interest rate, duration, customer ID have to be used, of course, right? So that is why in order to get it, in order to invoke this initiate loan function inside loan advisor class, it requires the loan object. Okay. So that is something like uses or relationship or association. And when we have the relationship in the class diagram, fine. How do you, it is like one-to-one relationship when there are two classes. Okay, relationship is between the classes or between the objects, right? So say there are two classes which are related. How are they related? Okay, they can have has a relationship, they can have uses a relationship, and so on. Fine. But one class can be related to another class with the different level of multiplicity. Okay. It is one-to-one aggregation, one-to-many aggregation, and one-to-many associations are possible. Remember, it is only for aggregation and association and not for inheritance. Is a relationship is called as inheritance, has a relationship is called as aggregation, and uses a relationship is called as association. And this multiplicity is possible only for aggregation and association. That is, has a relationship and uses a relationship, not for is a relationship. Okay. So the possible multiplicities are one-to-one aggregation, one-to-many aggregation, and one-to-many association. Before going with that, just look at the notation you use in the class diagram. When you establish a relationship using a dotted line or straight line or arrow or diamond or any relationship you establish between two classes, if there is something written as 1, it means it is 1 only. Okay. When you have star, then more than 1. When you have 0 dot dot 1, it is either 0 or 1. 0 dot dot star is 0 or many. 1 dot dot star is 1 or many. So in the aggregation or when you use has a relationship, two possible multiplicities are 1-to-1 and 1-to-many. Okay. Look at an example. Car is a class. Engine is another class. Okay. Every car has an engine, right? The relationship is has a relationship. It's very clear. Every car has an engine. Okay. The relationship is 1-to-1 because one car can have only one engine. Okay. That is why it is called as one-to-one aggregation or one-to-one relationship. Okay. 1-to-1 has a relationship. Car has an engine. So the relationship is has a relationship. Then one car can have one engine. So near to car you will write 1 and near the class engine you will write 1. That means it is 1-to-1 relationship. Look at the next example. One-to-many aggregation. Okay. Person has a credit card. It is possible, right? Person has a credit card.
So the relationship is, I cannot say person is a credit card. So is a relationship is not, right? So I can say that person has a credit card. I can also say person uses a credit card. That is also possible. But the simplest way is person has a credit card. Okay. But person can have 0 credit card, 1 credit card, 2 credit card, or multiple credit cards. Okay. One person can either have 0, that means he need not have the credit card, or he can have any number of credit cards. So it is one too many. One person can have any number of credit cards. Okay. Next, coming to the third type, it is one to many association. Okay. Customer uses the bank account. Okay. Customer uses the bank account. Customer cannot use a 0 bank account, right? Because when I say he is a customer of the bank, he should have at least 1 bank account. Only then he is a customer to the bank. Okay. That is why it is one to many association. One customer can have either 1 bank account or 2 bank accounts or 3 bank accounts or any number of bank accounts. But that customer cannot have 0 number of bank accounts in a bank. Okay, fine. So that is another type of multiplicity. So in every class diagram, this multiplicity has to be represented for every relationship you mention. Okay. Fine. Any doubts so far? Any doubts so far?
No, ma'am.
Okay. If there is no doubt, I will give you a case study. And when you come to the class next week, okay, can you draw the class diagram with all the relationships? I'll give you a hint of how many classes you have and so on. Okay. Okay. So I will just share the. Okay. You have a library management system. Okay. So library system should keep track of books. Book is further composed of details of title and copy details. Book title is about title, author, publisher, and catalog number. Individual copies maintain copy number, edition, publication number, ISBN, and book status. Okay, that is the individual copy of the book. Library also keeps track of uses. Okay, because it is a university library, there are several types of users, each user with a different privilege. There are faculties, graduate students, these are the types of users, okay, and undergraduate students. Fine. And every user will have name, address, and telephone number. For faculty, additional information is office address and telephone number. Fine. They are like any other user, but with an additional information. For graduate students, information such as graduate program and advisor information is maintained. The library also keeps information about library loans. See here, that loans is another class here. Okay. A loan occurs when a user borrows a book. Over a time, user can have many loans. Fine. So I want you to draw the complete class diagram with all the necessary classes, and for every class there are member variables and member functions. And once you get all the classes, you need to write their relationships and multiplicities among the classes. Okay, I want you to try it, and in the next class, let me see how many of you will be able to present your solution. Okay. Okay, at least 1 or 2, if you could do it, it is better. Okay. Fine. So
Ma'am, can you
can
send me
somebody?
this PDF?
I think it will be available for you in the recording, no dear.
Okay, yeah.
Okay, otherwise you can just click a picture of it now. All right, this is the case study. Please try doing it. Okay, it is helpful and you find it interesting. Fine. So what are the different classes? You have the books as one class. You have the users because it's clearly given there are many types of users. And all these three types of users are again the different classes: faculty, graduates, and undergraduates. Okay, three different classes. And as I said, there is a loan class. Fine. And you need to have another copy class because each copy should have the edition, ISBN, publisher number, and so on, right? That will be another class. And there is one more title class. If you see the first line there, they say the title will include author, publisher, some number, and so on. Okay, so there will be basically one books class, one user class, one loan class, and one faculty class, one graduates class, one undergraduates class, one copy class, and one title class. Okay, these are the minimum things. If you find any more classes, you can draw it and decide their relationships and multiplicity. Okay, so I will stop the class for today.